What is artificial lift? I think most of us must be having an idea, or you will have very familiar with this. Artificial lift is basically a mode when your natural reservoir energy is not able to produce your fluid from the wellbore to the surface. In that case, you are using some external mechanical support to produce your fluid from the wellbore to the surface. In this, you have the different techniques, different lift mode. You have the sucker rod pump, which is also called the beam pumping type, and you have the jet pump, you have the electric submersible, ESP, you have gas lift, and you have the PCP, progressive cavity pump. Other than this, you have also the plunger lift, which we will be talking about next. Like I said before, when your TPR does not intersect your IPR, you are going to use some of your artificial lift. Not just in this condition, before even when it's intersecting, if you predict that some liquid loading might occur, so you are going to use some of the artificial lift anyway. Out of this mode, you are mostly or commonly you are using the sucker rod pumping method and the plunger lift method for de-liquification in the gas well. Like I said, you have two types, the SRP and the plunger lift. SRP it has the sucker rod and it has the pump or the plunger inside your well, which will be connect with your surface unit by a sucker rod, and you have the traveling valve and the standing valve. I will be explaining in more detail regarding the SRP mode of de-liquification tomorrow. And so today I will be talking about only the plunger lift. So in plunger lift, you have the plunger, which will be set at the well, the perforation interval or above it. And this plunger will be using the natural energy from the reservoir. You don't need to have some external energy you don't require some external energy from the surface. So your reservoir energy will be lifting your plunger. Now let's discuss. Plunger lift system application includes the unloading of liquid that will load up in your producing wellbore, and it will reduce fallback between your reduce fallback of liquid inside your well when you are using intermittent gas lift. And also one thing is that we are proposing one method in Agartala, Tripura, I said, ONGC. We will be using plunger lift as a combination of intermittent gas. So it is basically plunger assistant intermittent gas lift. So we will be installing a gas lift valve as well as the plunger lift. So it will be used to reduce the fallback of liquid, right? It enhances the production in high GLR wells, and it will also clean up some of the tubing ID if there is some paraffins. The advantages includes it has no requirement of external energy. It will use the reservoir energy. It can be efficiently dewater some gas wells. No rig is not required. So you are installing this plunger lift using your wireline, which I will be explaining later on. And there is low cost artificial. This is a low cost artificial lift method, and it can handle gassy wells. It also be used in deviated well. And the limitation is that the GLR may be 700 to 10,000 volume by volume per 100 meter, and a low potential. It has low volume potential, which means that you will be able to unload a limited amount of liquid from your well to the surface. For the plunger lift, we have two components, the surface components and the subsurface components. In the surface components, we have this lubricator and connection system. And at the subsurface, you have, this is the plunger. We installed this in RO35 as a payload, but which was not successful because we are not, because of this plunger, it was stuck in the upper master valve. And I will also talk about that. And you have the tubing stop, and this is your bumper spring, right? And this will be the wellhead system of the plunger lift. The plunger lift at the surface, you have a controller, which is an electronic base, which will determine, which will be controlled with a parameter from the sensor, which will give some signal to either close or open your motor valve. This is your motor valve. And you have a transducer. It is an electronic device which will emit an electronic signal, and it will convert this signal into engineering units for the other system to be understand. And then you have the motor valve, which will basically close and open your valve. And you have a lubricator, or in the lubricator, you have a catcher here, somewhere here. It may be a manual catcher, or it can be an auto catcher also. And this is where your plunger will be catched. You can open, this is the handle. From this handle, you will be able to open this part using this handle. And you have some sensor here. You have one catcher here. So one arrival sensor will be there. This sensor will basically sense the vibration of the plunger when it arrives to the surface. And then as it arrives, the auto catcher will catch the plunger, and the plunger will sit inside this. And at the downhole, you have, of course, the plunger, and you have the bumper spring, and you have the tubing stop. Where to install the tubing stop or the bumper spring? Usually 1/3 of the interval of the perforation interval at the middle, or the 1/3, you are going to install this, not too high or not too low. In plunger, we have two types of plunger: the conventional plunger and continuous plunger. Conventional plunger, this is a conventional plunger. This is the bar stock type conventional plunger. In conventional plunger, you are going to have your valve shut, and then you have to open it again. Now you are putting your plunger to the plunger catcher, and you close the motor valve. Your plunger falls to the bottom. After it falls, you are going to monitor your casing pressure as well as your tubing pressure, and then you will decide when to open it. And then once you open your valve, your plunger will come up to the surface. Above the plunger, you will have your liquid. Below it, you will have gas. And then as the plunger arrives, your tubing pressure will increase, and you are going to, your plunger will be sensed by your sensor, and then your plunger catcher will catch the plunger. So like that, you are going to have a cycle. Your shut in, valve shut in, valve open, plunger arrival, and then valve closes. And again, after that, you will drop your plunger again. In conventional, continuous run plunger, you have two type. You have one type is your bowl or sleeve, and you have this dart type. The difference between this is that your plunger will be able to fall against the flow, so you don't need to shut your valve. This is hollow, and there is a flow path inside this dart type. This is dart type, like I said. So how this works? When you install one of these plunger, you are going to first you install your tubing stop. Above it, you install your bumper spring, and then you are going to drop this ball. You are dropping this ball above the bumper spring, and then you drop this plunger. When the plunger drops, this will be sitting above your ball, and it will seal this flow path. As it seals the flow path, some pressure will act below it, and from this, the clearance between the plunger and the tubing, some liquid and some gas will also accumulated above. And then when you have enough pressure to lift this plunger as well as this liquid, your plunger will surface, it will reach to the surface. And in the bumper spring, in the lubricator at the surface, you have one stick. When the plunger goes to the surface, this stick will, this plunger with the ball will hit the stick, and this ball will drop back to the inside the reservoir above the bumper spring. In dart type, when you drop your dart type, when you drop your dart type, when it hits your bumper spring, this dart will be pushed upwards. This part will be pushed upwards, and it will seal the flow part. Similar to that, as the gas pressure increases below the plunger, it will lift the dart type plunger along with the liquid above it, and when it hits the surface, because of the force, this will move back to its position, and then it will drop the dart type plunger, and some fluids as well as gas will flow through this because there is a flow path. There are some major concepts and some rule of thumb that we may use in designing or selecting wells for plunger. One rule of thumb is that you are going to require for your well to be completed with plunger. The minimum gas liquid ratio is 400 SCF per barrel per 1,000 feet. But in Weatherford, they use the old rule 300 and better rule of 1,000. But in ONGC, we are using this 400 SCF per barrel per 100 feet. And one limitation is that in your deviated well, your dogleg severity should not be more than 3 degrees per 100 feet, or it must be below 60 degrees. And for selecting wells for completing with plunger, you require some casing pressure, which will decide whether your plunger will reach to the surface when you open the motor valve. So the necessary casing pressure is that your line pressure, basically your line pressure is the flow line pressure, or you can use your separator pressure. Your line pressure, your casing pressure should be more than 1.5 times more than your line pressure. So this will eliminate, if your casing pressure is not more than this, you are not be able to use plunger lift in that well. And we have this load factor. Basically, load factor is the shut-in casing tubing pressure minus the shut-in casing pressure minus shut-in tubing pressure upon the shut-in casing pressure minus the line pressure. So this casing tubing pressure will decide how much fluid, how much liquid is there above the plunger. And this casing and the line pressure difference will decide, will the fluid be lifted with the pressure available, the casing pressure available. So for example, if you have your SICP of 400 PSI, your tubing pressure 200 PSI and line pressure 100 PSI, you have a load factor of 60%. This load factor should be less than 50%, but here you get a higher low pressure, so your plunger will not be reaching to the surface. Only when your tubing, let's say your tubing pressure is increased from 200 to 300 and you get your 33% load factor, only then your plunger will surface. That means your plunger will be rise to the surface and to the lubricator. And for calculation of plunger lift, the following parameters are assumed in ONGC. The fall velocity in gas is 666 feet per minute. And the fall velocity in liquid, we assume the 40 feet per minute. And the fraction of gas in slug, the fraction of gas in the liquid above the plunger is 80%. And then for your pressure required for your plunger lift, your plunger to lift it to the surface or to lift it, you need 5 psi. This will be depending on the plunger size also. You can calculate that using the pressure is equal to force per unit area. So you know the area, the volume of the plunger, and you will be able to calculate the pressure required to lift the plunger. And another thing you need to consider is the force and goal method. This will decide the minimum casing pressure. So based on this minimum casing pressure, you are going to decide and you are going to determine at what casing pressure in the surface you are going to open your well. This includes the pressure required for the plunger to lift, pressure required for the liquid, pressure required to lift the liquid above the plunger, and so on. Depth and depth of the tubing, the load size. The load size is basically volume of the liquid above the plunger. So how will we know when to open the well? And this is one equation which is modeled by Hassan and Hassan from Texas Texas A&M University, using the force and goal model only. Here, the casing pressure in this model, he calculated that the casing pressure is the required casing pressure is 269 after you are dropping your plunger to the well. When the casing pressure rises to 269, you will open the plunger. But actual casing pressure at the time of plunger release was 255, so which is 14 psi lower than the 269. So you are not going to sustain any continued production. And also, as a rule of thumb, you are going to consider your plunger rise velocity to be 500 to 10,000 feet per minute. And before that, you may also need to calculate your critical gas velocity, which we already discussed. This is a conventional plunger lift cycle. When you are dropping your plunger from the surface and after you close the well, your casing pressure will increase. At a point, you are shutting your well. As you shut your well, you will be notice in the surface your casing pressure and your tubing pressure will be increased. This distance is how much liquid is loaded above the plunger. So this is the shutting casing pressure minus shutting tubing pressure, which is the load pressure. And from and at one point, what you notice is this is the acoustic, the echometer. You are going to monitor your plunger fall velocity. Will it hit the bottom? Will it reach the bottom? At what time it reached the bottom? So that you will be able to determine how many cycles you need for one day for your plunger lift. So when the plunger hit the liquid level, you are going to see much more noise than your plunger is when it moves through the gas. And then at the second point, your plunger hit to the bottom, and then there is no noise because it reached the bottom. And then you wait for sometimes, because you decide that using like the previous formula of the casing pressure. When the casing pressure is reach its required casing pressure, you are going to open the well. As you open the well, there is a sudden decrease in the casing and tubing pressure. So your liquid will be moving towards the surface. As the liquid moves towards the surface, your casing pressure, tubing pressure, it will decrease because you are opening the valve. And when the liquid reach the surface, you are going to see a pressure spike in the tubing pressure because you are producing some liquid. So the pressure will be there. And also very high noise, this shade in the acoustic signal also. And when this is basically the afterflow. When you are going to produce some afterflow, after that your tubing and casing pressure will decline to the line pressure. This is the line pressure. And one thing is this distance will decide this much liquid ability to lift. So this distance is the lift pressure, and these two distance is the load pressure. Like load factor is the load pressure upon this load pressure upon this. So based on the load factor, you will be able to select the well with its GLR, with its casing pressure, whether the plunger will be surface or it will arrive to the surface or not. And there are some rule of thumb. We have, this is used by the echometer company. We have the rule of thumb like the volume of liquid in the tubing, height of gas liquid. I will be sharing this with you, the Excel sheet. So based on this rule of thumb, there is a spreadsheet for the plunger lift design. You have this spreadsheet. You need to have only the casing ID, tubing ID, casing ID, the casing pressure, the pressure to lift your plunger, the line pressure, gas gravity, and all these things. So based on this, you will be able to calculate how much liquid is there in the tubing, what is the height of the gassy liquid, what is the fall through time of the plunger through gas, through liquid, the total fall time, and then how much pressure you will be required for your casing pressure to lift. So you will be able to calculate from this Excel sheet all these requirements, which I will be sharing with you. And for plunger installation, you are, the first thing for surface installation, the first thing you are going to require is you need to remove your master valve. Above this, you are going to install your pump lubricator. And then you will modify the lubricator, the flow line, the ball, and the T with this flow line for gas and liquid. And for installing the, and then after installing the bumper spring above the upper master valve, after you removing your swept valve or the crown valve, it will be looking like this. And then for installing the bottom hole assembly, which includes the tubing stop, the bumper spring, as well as your plunger. So basically, you will be running your tubing stop inside your 2.7x8 inch tubing, depending on the tubing. Their tubing size may be different, but here in Agartala, we are using tubing size usually is 2.7x8. Before you put your tubing stop or your bumper spring, I would suggest you run some scraper trip so that you will be cleaning your tubing, because most of your well, which will be using the plunger lift, will be flowing more than 10 to 15 years. So you will be cleaning your tubing, and then you are attaching your tubing stop with your wire line. You lower it down to the determined depth. And then after that, you are going to lower your bumper spring above the tubing stop, and then you will be dropping your plunger from the lubricator. So what you do is, this is the plunger catcher. You will open this. First, you will close this valve, or you will turn on your auto catcher. It will catch your plunger. You open this, you put your plunger, and you close this and tighten it. And then you open your catcher or your valve, and then the plunger will drop. So one thing I wanted to share is that in RO55, we are using, like I said, we have done a plunger. We have installed one plunger for a payload. But the problem is that the plunger arrived to the surface only 2 times because one thing is that when we drop the plunger, it stuck at the upper master valve. It stuck here, the plunger stuck here. So make sure your master valve is fully open before you drop your plunger. And after that, we are, instead of dropping the plunger, we lower the plunger inside above the bumper spring using the wear line, and we put the plunger to the above the bumper spring, and then we reel out the wear line, and then we wait for the casing pressure to reach the required casing pressure. And only one time it the plunger surface, and after that the plunger is not arriving to the surface because of this well was deviated. And I'm going to show you one deviation. This is the well was deviated, and when we are calculating our dogleg severity from the, now I'll just show you how we calculate it. When we calculate the dogleg severity, at some point the dogleg severity was higher than 3 degrees per 100 feet x second. You can even use your Excel to draw this also. Now, let me just reverse this. Second. I will just, it is from 3000 depth, 3000 meter. I will reverse it from 0. Now, what we can see here is that the dogleg severity, this is basically the measured depth versus the dogleg severity. So at this depth, the dogleg severity was 3.6. As you can see.
Not visible.
Excuse me, sir. This is not visible, sir.
It's not visible. Okay.
Yes,
No,
sir.
sir.
Okay, so I will share with you this before testing also. Okay, because maybe due to some restriction in the sharing of the screen, I think only PPT is visible, right?
Yes, sir.
Okay, maybe that's the problem. So the problem here was that when we used plunger, when we tried to use the plunger in this well, the problem is that at depth around 2,500, the plunger was around 2,600 meter. And at around 2,500 meter, there was a dogleg severity of 3.6. Above that, there was a dogleg severity of 3.2. So because of that dogleg severity, our plunger was stuck there. So it is very critical to determine all the dogleg severity for your well before you are using your plunger. And then we try to remove our plunger using some coil tubing. We pump some nitrogen from the annulus. We did reverse circulation, even though we try it with very high pressure, more than 70 kg. We are not able to retrieve the plunger. from the downhole. So we retrieve the plunger. Because of that, we have lost more costs. It will cost more because of the workover rig. And one thing, the recommendation would be for the plunger lift, it is very essential to determine the fall velocity using your echometer or the acoustic fluid instrument. And you should determine your minimum shut-in time, which will maximize the number of cycle per day. The more the cycle you can have in your